Hey everyone, welcome back. It's me, the part-time economist, and in today's video, I'm going to show you how to do a linear regression analysis in Jamovi. It is going to be super simple, it's going to be super easy, and we're going to break it all down for you. So with that being said, let's go ahead and jump right in. In this example, I have created a completely fake data set, and I have included the student's grade point average, the number of hours that they study per week, whether or not they are a student athlete, and their ACT score that they used when they were applying to college. Now, what I want to do is I want to analyze how all of these variables influence the student's grade point average. Now, the way that I'm going to do that is by going to Analysis. I'm going to click on Regression, Linear Regression. And this is why I love Jamovi. It is so simple. All I have to do is move the dependent variable, obviously, to the dependent variable box. Now, this is where things do get a little bit interesting because there are two different ways of incorporating explanatory variables, right? If we list it as a covariate, right? So if I move hours to covariate, it is going to treat that as a numeric variable, right? A student can study for 1 hour, 1.5 hours, 1.6732 hours, right? It can be represented as a numeric variable. Now, what you'll notice is that if I tried to move, let's move this backwards. If I tried to put hours as a factor, it wouldn't let me do it because there's a data type mismatch. So when we are looking at factors, those are the categorical variables, right? So if someone is a student athlete, they are or they aren't, right? I'm going to put that as a factor variable. Now, some things could get construed either way, right? If we are doing the number of cylinders that a car has, right? Maybe it's 4 cylinders, 6 cylinder, 8 cylinder, right? Those are distinct categories, but they are represented as numbers. So it's important that you understand how you're representing things. Now, in this example, ACT, right? ACT score, I think it ranges from like 0 to 32 or 36, something like that. You can't really get like a 29 3/4 on your ACT, but for the purposes of this analysis, I'm going to list it as a covariate. What you'll notice is that it creates the linear regression output for us. So we have R squared, right? That is how much variation in the dependent variable that our model is explaining. We are at 0.791, which is really high, but again, I had the privilege of being able to make up this data set however I wanted it to be. So if your R squared isn't that high, don't worry too much about it. That being said, we also have the equation itself. So we've got the intercept. We have got the coefficient for each of these variables, right? So for every additional hour that the student studies, we associate that with a 0.17 increase in the grade point average. Obviously, you can see here, being a student athlete is associated with an increased GPA, and then also the higher ACT score, we tend to associate that with a higher grade point average. We've got our p-values, we've got our t-statistics. Now, again, I'm not going too deep into the interpretation. I'm more just showing you how to do things in Jamovi. So if you don't know what these statistics are, I would recommend looking those up. Now, a couple other things that I do want to discuss related to validating the model, right? We can do the normality assessment. So in this example, we are doing Shapiro-Wilk test. We are rejecting that assumption of normality. Again, keep in mind, with linear regression, the normality assumption, it is important, right? But as you get a big data set, it's going to become increasingly likely that you reject normality. So keep in mind that rejecting normality on a linear regression doesn't automatically mean that your model is terrible and you can't use it, right? Keep that in mind. That LM models are robust to violations of that assumption. Now, a couple other things that we do want to check for. We can do the collinearity statistics, right? So, when you're doing regression analysis, you want to be checking for multicollinearity. We can do QQ plots of residuals, residual plots. Now, a couple other things that I do want to show you. Obviously, autocorrelation here, it doesn't really apply. We're not doing time series, but if we wanted to do that, we could do it. We could calculate Cook's distance. And one thing that I do really want to show you here, let me see where this is at. We can save specific values, right? So if we were wanting to save the predicted values, the residuals, right? Maybe we are wanting to do something kind of further on down the line with those values. We can do that, and then when we go back to the data tab, it's actually going to save those for us, right? So if there was a situation where we needed to specifically report each individual residual, we could do that. So as always, this video is just an overview. It's just trying to explain the basics. Like I said, if you want more info on the specific statistics, why I was doing certain things, that is a different video. But as always, thanks for watching. I hope you enjoy the rest of your day.